Hello everyone, hope all of you are doing well. In the last video we were discussing the previous question papers and answers from the chapter Units and Measurements. Today also we can continue with the same. Are you ready to go with the first question? The first question is from the year March 2016. This is a 4-mark question and the question is A. The error in the measurement of radius of a circle is 0.6%. Find the percentage error in the calculation of the area of the circle. And B. Name the principle used to check correctness of an equation. And C. What is the number of significant figures in 0.00820 joule? Now we can answer the questions one by one. The first question is given as the error in the measurement of radius is given as 0.6%. We have to calculate the percentage error in the area of the circle. Okay, so first of all we can write down the given quantities. So that will be delta r by r, that is the error in the measurement of radius, that is 0.6%. And we have to calculate area. So what is the area of the circle? Yes, that is pi r square, right? So A is equal to pi r square. Now we can find the percentage error in the calculation of area, that is delta A by A, that is equal to 2 into delta R by R. So the value of delta R by R is 0.6, therefore 2 into 0.6, that will be 1.2%. Okay, now the next question is to name the principle used to check the correctness of the equation. Yes, that is the principle of homogeneity. According to the principle of homogeneity, in any correct equation, the dimensions of all terms must be identical. In this question, we have to find the number of significant figures in 0.00820 joules. Okay, so here we have a number less than 1. Also, in this case, the zeros on the right of the decimal point, but to the left of a non-zero digit are not significant. Okay, so how many numbers will be here? How many significant figures will be here? That is, we have that 0.00820. So these two zeros are not considered. So the total significant figures are 3. That is 820 only. Okay. Is it clear? Now we can move to the next question. The question is asked in the year 2015 SCERT examination. Okay. This is a 4-mark question and there are 3 parts for this question. The first one is the correctness of equation can be checked using the principle of homogeneity. State the principle of homogeneity. So that is a 1-mark question. And the second part is using this principle check whether the following equation is dimensionally correct. That is half mv square is equal to mgh, where m is the mass of the body, v is the velocity, g is acceleration due to gravity and h is the height. For this question we will get 2 marks. The third question is if percentage errors of measurement in velocity and mass are 2% and 4% respectively, what is the percentage error in kinetic energy? This is a 1-mark question. Are you ready to answer the question? Yes. So we can answer it one by one. What is the first question? Yes, we have to state the principle of homogeneity. Yes, we have studied the principle of homogeneity, right? What is it? Suppose there are more than 2 terms in an equation. Then, in order to check the correctness of the equation, we have to find the dimensions of each term. And the dimension of each term must be the same. Then only it will be dimensionally correct. So, how we can state it? Yes, the statement is in an equation containing more than 2 terms, the dimensions of each term must be the same. Now we can answer the second question. What is second question? Here an equation is given, that is half mv square is equal to mgh. We have to check whether the following equation is dimensionally correct. Okay, we know that here m is the mass of the body, v is velocity, g is the acceleration due to gravity and h is the height. Okay, so that we can find the dimension of half mv square and also mgh. Right, so what will be the dimension of half mv square? Is there any dimension for half? No, because that half is a constant, right? So for constants there is no dimension. And what about mv square? M is having the dimension capital M. And what about v? Velocity. Velocity is displacement by time, that is L by T. That will be Lt raised to minus 1. So how we can write? Half mv square is equal to m into Lt raised to minus 1 the whole square. So that will be m L square T raised to minus 2. Now we have the dimension of half mv square as m L square T raised to minus 2. Right, now what we have to do? We have to find the dimension of mgh. Right, so what will be the dimension of mass is m itself. Right, then g is acceleration due to gravity, that is velocity by time. So Lt raised to minus 1 by t, that will be Lt raised to minus 2. And h is again L. So what we will get? That will be m L square T raised to minus 2. So that means the dimension of both the sides are the same. Hence the equation is dimensionally correct. Okay, so both the dimensions are m L square T raised to minus 2. Therefore, we can say that the equation is dimensionally correct. Now we can answer the third question. What are the given quantities in third question? Yes, it is given that the percentage errors in the measurement of velocity is 2% and the percentage error in the measurement of mass is 4%. Okay, then we have to calculate the percentage error in kinetic energy. So first of all, we can write down the given quantities. Here the percentage errors in velocity and mass are given. Then we have to calculate the percentage error in kinetic energy. Right. So what is the equation for finding kinetic energy? That is half mv square, isn't it? So that how we can find the error? Kinetic energy half mv square. Here half is a constant, right? Is there any dimension for half? No, there is no dimension for constants. So that what about m? What is the error in m? That will be delta m by m. So that value is given as 2%. So that we can write down that delta m by m is equal to 2% and delta v by v is equal to 4%. Now what will be the percentage error in kinetic energy? That will be delta Ke by Ke, right? So how we can write? Delta m by m plus 2 into delta v by v, because this is a product. So in the case of product of two numbers, we have to add the relative errors of each terms, right? So that will be delta m by m plus 2 into delta v by v. Now we can substitute the values, right? So what we will get? Delta m by m is 2%, so that is 2% plus 2 into delta v by v, so that is 4%, so that will be plus 2 into 4%, so total will be 10%. Okay, is it clear? Can we move to the next question? Okay, the question is from the year March 2015. This is a 3-mark question and 3 questions are given here. The first one is suggest a method to measure the diameter of the moon. Second one, length, breadth and thickness of a block is measured using vernier calipers. The percentage errors in the measurement are 2%, 1% and 3% respectively. Estimate the percentage error in its volume. The third question is a physical quantity is given by h is equal to fv square by L. Here F is the force, V is the velocity and L is the angular momentum. Find the dimensions of H. Now we can answer the questions one by one. The first one is very easy question, right? What was the question? Suggest a method to measure the diameter of moon. Yes, what is the method to measure the diameter of a moon and large distances? We have studied, right? The method is, yes, that is parallax method. So that parallax method can be used to measure the diameter of the moon. Okay. Now we can answer the second question. What are the given quantities here? The given quantities are the percentage errors in the measurement of length, breadth and thickness. And it is given as the 2%, 1% and 3% are the errors. Okay. Now what we want to calculate? Yes, it is the volume. So how we will calculate the volume? Yes, we have the equation, that is length into breadth into thickness, that is V is equal to LBT, right? So what will be the percentage error in volume? That will be delta V by V into 100. So that how we can find, this is a product, right? So we have to add the relative errors. So that will be delta L by L into 100 plus delta B by B into 100 plus delta T by T into 100. Now we can substitute the percentage errors. What is the percentage error in length? That is 2%. That is delta L by L into 100 is 2%. Right. Then plus delta B by B into 100. How much is that? That is 1%. So 1% plus then delta T by T into 100 is 3%. Then that 3 also we can substitute. So that will be 2% plus 1% plus 3%. So the answer is 6%. Clear? Now can we move to the last question? Yes. Here a physical quantity is given as H is equal to Fv square by L. We have to find the dimension of H. And we have F is the force, V velocity and L is the angular momentum. So that we can find the dimension of each terms. Right. What will be the dimension formula of F? That is force, right? M into A. Yes, that is mass into acceleration. Then what will be the dimension? That will be mass M into acceleration is, yes, L by T square, right? So M L T raised to minus 2 is the dimension. Then what about velocity? Velocity is displacement by time. Okay, then what will be the dimension? L by T. So M0 L T raised to minus 1. And what about angular momentum? How we can find the dimension of angular momentum? Angular momentum is equal to moment of inertia into angular velocity. Don't be confused with the new terms because all the three terms will not be familiar to you, right? But in our chapter system of particles and rotational motion, we will study it in detail. Okay, so then we can understand the equations and dimensions and all. But now we have to know only the dimension. Okay, so we can just go through the dimension of this. Now the equation for finding angular momentum is equal to moment of inertia into angular velocity. Okay, so again the moment of inertia is also a new term, right? So the equation for finding moment of inertia is mass into distance square. Then it will be easy to find the dimension. So what is the dimension of moment of inertia? Mass is m into distance square, that will be L square, and then m L square T0 is the dimension of moment of inertia. And one more term is here, no? So what is that? Angular velocity. Yes, angular velocity is equal to angle by time. Then we can find the dimension, right? So the dimension of angular velocity is 1 by t, that is m0 L0 T raised to minus 1. Now we can find angular momentum, right? Then that is angular momentum is equal to moment of inertia into angular velocity. Then what we will get? Angular momentum is equal to moment of inertia is m L square T0 then into m0 L0 T raised to minus 1. So what will be the total? Yes, that is m L square T raised to minus 1. So that is the dimension of angular momentum. If it is very difficult to remember all the terms and equations of angular momentum, we can easily find it from the unit, right? What is the unit of angular momentum? It is kilogram meter square per second. So you have to remember only the unit, that is kilogram meter square per second. So how we can find the dimension? We have kilogram, that means it is a unit of mass. Right. So how we can write? Instead of kilogram we can write m. And what about m? Meter, that is the unit of length. Right. Here we have meter square, that means L square. And per second means second raised to minus 1. Right. So that will be t raised to minus 1. So that we will get the dimension as m l square t raised to minus 1. Now we have the dimensions of all the three terms, that is f, v and l. Now can we substitute? Yes. Then what we will get? H is equal to f. F is ml t raised to minus 2 into v is l t raised to minus 1. So v square means l t raised to minus 1 the whole square divided by l. L is m l square t raised to minus 1. Okay. Then what we will get? The m and m will get cancelled. Then l square, that one l will get cancelled here. Then what is remaining here? L t raised to minus 3 only, right? So the answer is L t raised to minus 3. That is the dimension of H. Is it clear? Now we can conclude. Okay. So if you like my video, please like, share and subscribe. Thanks for watching.